All right, hey everyone, and welcome to the talk today, where we'll be discussing common patterns for provisioning access into AWS accounts for your cloud builders. So my name is Jesse Fuchs, and I'm also joined by Yuri Dekovny, and we're both solutions architects at AWS.
Hello, thank you for joining us today.
So this is a 300-level session, so we're expecting some existing knowledge of standard identity topics, such as identity federation and some of the core AWS identity and access management building blocks, such as AWS IAM users, groups, and roles. So the learning objectives all really revolve around federation into AWS. So if you take one thing away from this talk, it's really that you should be using federation for getting your cloud builders access into AWS accounts. And the three patterns we'll be covering under that federation umbrella will be bringing your own identity provider, leveraging a native AWS service as your identity provider. So it's going to be using AWS Single Sign-On and leveraging a combination of both of those together. So the traditional approach in the past for accessing an AWS account has been to use AWS IAM users, where essentially you would create a unique identity in that AWS account for each one of your cloud builders. You'd generate standalone credentials, and then you'd put that user in different AWS IAM groups to provide more fine-grained access control into the services and resources in that AWS account. So this is something that's still available, but it's really not the recommended pattern anymore for provisioning human access into AWS accounts, as there's some challenges with this pattern. So over time, you start to add additional AWS IAM users into that AWS account. So essentially, you have numerous cloud builders with different roles and responsibilities. And then you start to move towards a multi-account structure, since it's really a best practice for architecting on AWS. So there's a lot of benefits for having multiple accounts, such as running into any sort of service limits, so you can get different limits by having multiple AWS accounts. Maybe you want to isolate different teams into different AWS accounts so they're not stepping all over each other. Maybe you need to isolate workloads based off of security and compliance requirements. And so the AWS account is still the best isolation boundary. Maybe you want to, you have different business units or products that need their own AWS accounts. And then an account is really the only true way to separate things at a billing level, right? But with multiple accounts, if you're trying to go about creating AWS IAM users and groups and use that pattern for provisioning access into those accounts, you end up having to create those users and groups in every single AWS account. So each user here, Alice, Jane, and Bob, would essentially have a separate identity in each AWS account. You'd end up with credential sprawl, where they have a credential per AWS account. They'd probably end up using long-term credentials. So if they needed programmatic access, they would essentially be using static access keys. And then as it relates to compliance, if you think about how you'd go about deprovisioning or provisioning users or doing any sort of entitlement auditing, it becomes a huge pain where you'd actually have to build a lot of automation to do all of those things. And then lastly, the user experience ends up being incredibly poor. So each user has to maintain like a list of sign-in URLs for each one of their AWS accounts, and has to actually remember passwords for each one of those accounts as well. So the primary access pattern has really shifted from using standalone AWS IAM users to using identity federation, which essentially means you're linking a single identity to all of your AWS accounts so you can access them with that single identity or that single credential. So that identity is typically an existing corporate identity. So by using federation, you're really moving towards a model of centrally managing your users' credentials and their entitlements. Those credentials are now short-lived based on a customized duration. And then compliance becomes more unified. So you're able to leverage existing investments into some of your processes and tooling. So you can, leverage existing deprovisioning and provisioning processes you already had in place for your corporate identities. And the user experience is significantly improved since it provides single sign-on to AWS accounts for users. So federation is really the preferred pattern for accessing AWS. Now let's dive into some of the most common federation patterns that we see. There's three common patterns that we see the most. The first one is AWS IAM federation, where you're using an external identity provider. The second one is AWS SSO federation, where you're using AWS SSO as the actual identity provider itself. And then you have a combination of both of those where it's still considered AWS SSO federation, but you're leveraging an external identity provider. So with the first one, AWS IAM federation, you're essentially setting up a trust between each and every one of your AWS accounts and an external identity provider, such as Okta or Ping or OneLogin or Azure AD. So what does that configuration actually look like? Well, on the left, we have our external identity provider configuration, and there we create a relying party. So we configure basically the trust on the IDP side for the service provider, as well as set any sort of specific configurations, such as claims transformations or the addition of any sorts of SAML attributes that we want added into the actual SAML assertion. We would then create groups in the directory for that external identity provider. So if we're using Okta as our IDP, maybe we're using their built-in universal directory, or maybe we have that Active Directory hooked into Okta. Whatever our directory source is, that's where we'll be creating these groups. And I mentioned create matching groups, and we'll get into what that actually means here in a second. And lastly, you would add users to those groups. On the right side, we have our AWS configuration. So this is where we would actually go and create an AWS IAM identity provider, which essentially is just informing AWS about that external identity provider and its configuration. So it's the other side of the trust. And so after we set this up, we've now established the trust on both sides between the identity provider and the service provider, which is the AWS account. And after that, we would essentially create the AWS IAM roles with a trust relationship between AWS IAM and the external identity provider. So this is something that we're going to have to end up doing in every one of our AWS accounts. I mentioned before about creating groups on the directory side and the AWS IAM roles on the AWS side. Well, the most common pattern today for entitlement mapping is really the one-to-one mapping, where you'd essentially create a group within your directory source with a certain nomenclature that maps directly to an AWS IAM role in a single AWS account. So the creation of the groups and roles can be created or automated depending on the business processes and tooling that you have in place. But this really allows you to control the coarse grain entitlement mapping within your own directory so that users can have access to only a subset of the available AWS accounts and possibly different roles in those accounts. And as the number of accounts and roles grows, so does the amount of matching groups. So in this case, you can see we have two different AWS accounts where you have essentially the same roles in each one of those AWS accounts. And we have 6 different groups that we need to create in our directory source. And so you can see the actual nomenclature of the groups themselves. We actually include information about both the AWS account and the name of the role. So we start with this AWS dash prefix. This is just an example of a nomenclature for a group, but with certain identity providers, you can configure claims transformations that essentially will pull in a bunch of groups that start with a particular prefix. You can also, if you're going through and searching through your directory, it's a lot easier to see that these groups are essentially being used for AWS entitlement mapping. Next, you'd actually set the account number, which matches to the actual account number you're trying to assume the role in. And then finally, it's the actual name of the role itself. On those AWS IAM roles, we set a trust relationship between the AWS Identity and Access Management and the external identity provider. So this is essentially just a resource-based policy that you would apply to the role to define the principals who are able to assume this role. So you can see under principal, we're allowing federated principals from this external IDP. Under action, we have the STS assume role with SAML action. So essentially, we're able to pass in a SAML assertion to assume this role. And then finally, we have the a conditional that requires this SAML audience, which basically just makes sure that the role is assumed only for sign into the AWS Management Console. You can further extend this trust relationship to require session tags. So AWS session tags are extra attributes that an IDP like Okta can add to SAML assertions, and they are appended into your session token. So they're constrained to the returning set of temporary AWS credentials. You can see we've added a new action. So we've added STS tag session, as well as a new condition. So in this condition, we're requiring two specific tags. The user can be part of any division to assume this role, but they require that division attribute to be passed in as a tag. But they have to be part of the Blueberry team, which happens to be a cross-functional team across multiple divisions. And these tags can be used for a variety of different things. One of the primary use cases for these tags would be for attribute-based access control, where you can set access based on matching principal and resource tags, or you could just set additional attribution context for a federated principal. So when you're doing any sorts of audits through your CloudTrail events, you'd be able to identify some of the additional context around that particular user. So let's walk through the user flow. In orange, we're going to basically outline the user actions, and then in gray, we'll have the transparent actions that kind of happen behind the scenes. So first, we have a cloud builder that would browse to a URL and authenticate. The external identity provider, in this case it's Okta, would generate a SAML response. It would send that back to the browser. The browser would relay that response to AWS, and then AWS would present the user with a menu of roles that they could select. If we take a closer look at the actual SAML assertion, we're going to outline a number of the attributes that are really important here. The first one is going to be the attribute for, the role attribute. And this is going to include, as you can see, the kind of pair matching of the AWS IAM identity provider and the associated AWS IAM role. So when we talked about claims transformations or those kind of the nomenclature for those groups, essentially what your identity provider is going to do is take that information, so that account ID and that role name, and automatically construct these Amazon resource names, and then it's going to put them into this role attribute. So if you have access to 25 roles across a bunch of different AWS accounts, it's going to take all of those roles and essentially put them in this specific attribute. And that's essentially one of the constraints of this pattern here. So if you have access to a bunch of different roles across hundreds of AWS accounts, you could essentially run into constraints related to the size of the SAML assertion you're able to pass. So just be aware that as you kind of start doing your entitlement mapping, that you could essentially run into size constraints related to the SAML assertion. But if you run into that type of situation, you should probably reevaluate the need for that level of access across all of those different accounts to see if there's a better mechanism. Another attribute that's important here is the role session name. So this really allows you to pass in a unique identifier for the user, which can be used to attribute actions for that user in that AWS account. So essentially, when you go and do any sorts of audits against your CloudTrail logs, you'd be able to attribute certain actions back to this particular user. So in this example, I passed in the user email as the role session name, but in some cases, you may want to just pass in a unique identifier for that user to avoid directly passing in any sort of personally identifiable information. And lastly, the session duration. So this really indicates the duration of the actual credentials. And this is set when you configure the relying party within your external identity provider. So in this case, I just set it at 1800 seconds or 30 minutes. That SAML assertion is relayed to the AWS SAML endpoint, which basically extracts all of those accounts and roles and presents the end user with a page like this. So it's essentially their menu of roles that they can select. And so they'd essentially select whatever role they want to assume. So the user selects the role, an assume role with SAML API calls made to the AWS Security Token Service. AWS credentials are returned back to the actual cloud builder, and the user is redirected into the actual console. So in this first access pattern, Okta, or external identity provider, is our identity provider, and our AWS account is our service provider. And since we're initiating this flow from our external identity provider, this is known as an IDP-initiated SAML flow.
And if we summarize this access pattern, it's known as AWS IAM Federation. So the identity provider, the user directory source, and credentials, including the MFA controls, are all configured externally. There's no support for AWS organizations, and we'll get into more about why AWS organizations is important when we talk about AWS SSO. The AWS IAM management is decentralized, so this really relates to the management of the IAM resources, like the AWS IAM identity provider and the roles. And it's decentralized since you have to actually create those in each and every one of your AWS accounts. There are mechanisms you could put in place as far as automation goes to centralize that, but by default, you'll have to go configure those resources in each AWS account. Immutable AWS IAM roles. So this is really about ensuring principals can't modify roles created for your cloud builders. So whether that's modifying the permissions or policies attached to those roles or deleting those roles. Immutable AWS IAM roles kind of falls under that idea of creating security invariants, where you're creating immutable security controls. So you could do this with IAM policies, but most customers are using service control policies as the primary control for setting security invariants, since you're able to do it a lot easier at scale. Still, the most common subpattern for entitlement mapping is the one-to-one group to role mapping. So as we talked about, this is where you have a single group in your directory source that maps directly to a role in an AWS account. CLI support. This is if your cloud builders need federated programmatic access to your AWS accounts. Right now, for this pattern, you have to rely on open source or homegrown solutions. And then pattern maturity. This is really about showcasing the adoption of this pattern by customers. And this AWS IAM Federation pattern is really a leader and is the most used pattern today since it's really been around the longest.
Next, we'll move on to AWS SSO Federation using AWS SSO as the actual identity provider. So this is a use case where you may not have an external identity provider and you just want to leverage a native AWS service. So just a quick primer for those who aren't familiar with AWS SSO. It's a native service that really allows you to centrally manage single sign-on access. So it allows for flexible directory options. You can manage AWS account access at scale, and you can provision single sign-on access to AWS integrated applications as well as business applications. But really what we're focused on in this talk are these first two about flexible directory options and managing AWS account access at scale. Before we jump into the configuration of AWS SSO, we really need to spend a minute talking about AWS organizations, since it's really a foundational service that all customers should be using to better govern and manage their AWS accounts at scale. And it's really a key part as to why AWS SSO is able to manage AWS account access at scale. And one of the important features we're talking about in this specific talk is trusted services. So this is a feature of AWS organizations that essentially allows you to enable trusted access for another AWS service, so it's able to perform tasks in your organization. So first, you want to make sure you're using AWS organizations. You want to make sure you're using it in all features mode. So this just really gives you access to advanced features such as service control policies and trusted services, which is the feature we're focusing on here. Next, you want to enable trusted access for AWS SSO. This is done pretty much automatically once you first enable AWS SSO. And then after you've done that, there's actually an AWS organization's service-linked role. A service-linked role is really just a unique type of AWS IAM role that is linked directly to an AWS service. So it's only assumable by that AWS service. And when you start to use AWS organizations, this is automatically created in all of your member accounts. And what this service linked role will actually do once you start to use AWS SSO as a trusted service is it will go and automatically provision an AWS SSO service linked role in each one of the AWS member accounts that you're actually using. And so what this AWS SSO service linked role would actually do is provision and deprovision resources in that actual AWS account. You can configure AWS SSO first by setting a identity source. So if you're looking at using AWS SSO as your identity provider, then this would be the built-in AWS SSO directory or Active Directory. Then you would create permission sets, which are essentially just templates or definitions for AWS IAM roles. You'd assign users or groups to AWS accounts with the desired permission sets. And then when you actually assign that user group to an account with a desired permission set, the AWS SSO service linked role will actually connect to that AWS account, create the AWS IAM identity provider, and the actual AWS IAM roles based off of those permission sets, which really are kind of the definition of those roles. And these roles that are created by AWS SSO are actually managed by AWS SSO as well. So they're essentially immutable. So no principal in that AWS account, whether it be the root user or an administrator, can actually modify or delete those roles. And since they're inherently immutable, there's really no reason to add to your service control policies.
So what are these AWS SSO permission sets? Well, you can think of them as role definitions. Within AWS SSO, you can create a permission set and assign policies to that permission set. So in this case, you can assign AWS managed policies and an inline policy, but it's important to note that customer managed policies aren't yet supported. And then you can set a session duration, which basically sets the duration of the temporary credentials. Now that you have the role definition, whenever a user or group is assigned to an AWS account with this permission set, an AWS IAM role and the associated AWS IAM identity provider are automatically provisioned based on the definition. And that trust between the identity provider and the service provider is automatically set up. And you can see the roles are created with a standard nomenclature. So they're prefixed with AWS reserved SSO. So if you ever needed to search through your roles to determine which roles are being managed by AWS SSO, that could be one indicator. But you can also look at the path for the particular resource. You can see the permission set name is also included, and then there's a unique hash that's appended at the end. So what does the group to role mapping look like in this access pattern? Well, we're actually going to walk through a couple different entitlement mapping patterns since AWS SSO really allows you to be a lot more flexible in the mapping. In this example, you'll notice that there really isn't a mapping required. So you get to manually assign a single group to a bunch of AWS accounts with whatever combination of permission sets you'd like. But since everything is manual, it doesn't necessarily scale very well. So if I were to put a user and add them to this particular group, they would have access to all 4 of these roles. So as part of the DevOps team, I'm able to assume the DevOps engineer role in all of the accounts, but I also need the read-only role whenever I just need to check the configurations of certain resources. So this would be pretty good if you're doing manual assignment management, maybe part of a smaller organization where you had a small number of groups and AWS accounts, but probably won't work well as the primary entitlement mapping pattern for a large organization. Before we talk about more scalable patterns, we should first highlight the launch of the new AWS SSO account assignment APIs and CloudFormation support. So you can use the APIs to retrieve permissions programmatically for audit and governance purposes, and they enable you to really automate the management of permission sets and assignments, making it a lot easier to manage access at scale across all of your AWS accounts. So using the CLI v2 or the SDKs, you can create permission sets and attach AWS managed policies to them. You can assign those permission sets to AWS users and groups in the desired accounts. And you can query the existing permissions and assignments from the CLI. And Yuri is going to be giving a demonstration of this later on. But it's really because of the launch of these APIs that we can start to look at more scalable entitlement mapping patterns. So as mentioned before, you can assign flexible group to permission set combinations to multiple AWS accounts. So for large scale deployments, you can choose to have a one-to-many mapping between your groups and roles. In this example, you can see that we have a standard nomenclature for the group and permission set. And our automation, which leverages the newly released assignment APIs, can extract the permission set name from the group. So in this case, it's DevOps Engineer. So it's extracted from the group, and then that group is assigned to that permission set in all of the AWS accounts in the AWS organization. So this is an interesting pattern if you have roles that you need to deploy in every account, but it's very coarse-grained entitlement mapping. You can see we added a little note about the permission set to OU mapping for this pattern as well. The group to role mapping is really highlighting the role association given to a user when they're added to the group. So in this case, you can see if I were to add a user into this group, this AWS-DevOps-Engineer group, they would have access to assume these roles. But there's also a mapping between the permission set and OU, or in some cases, the mapping between the permission set and AWS accounts. So if you were to reuse a permission set, a change to that permission set will change the configuration for each role that the permission set defines across your AWS accounts. So if I were to come in here and add the EC2 full access policy to this permission set, all roles that were created based on that permission set will be updated, which may or may not be intended. If we wanted to get a little more fine-grained with the mapping, you could set up your assignment logic automation to extract both the permission set name and the organizational unit name from the group and assign that group with the DevOps Engineer permission set, in this case, to all of the AWS accounts in the data science organizational unit. This requires the automation to query AWS organizations to list out the accounts that are part of that organizational unit. So now you're automatically assigning a group to a permission set across just a subset of AWS accounts rather than all of them. And you can see the permission set to OU mapping is still one-to-many. So any change to that permission set will affect the downstream roles, including those outside of the data science organizational unit. So if that permission set is used in a different organizational unit. So you can see here, if I were to add a user to this group here, they would be able to assume both of these roles. You can see this dotted line in light blue here. And basically, since I'm reusing this permission set across AWS accounts in different organizational units, that the configuration of this role is defined by this permission set, but just because a user is in this group does not mean they have access to this role. If we wanted to have tailored permission sets for certain OUs, you could create OU specific permission sets. So any changes would only affect the roles in that specific OU. But you'd still be assigning access to a subset of AWS accounts like the pattern we saw before. So you can see here that there's a data science OU with a DevOps engineer permission set dedicated specifically to that OU. And then there's another permission set that's also based on the DevOps engineer job function, but it's specific to a separate organizational unit in case the permission sets have to vary in their configuration. So if I were to add a user to this group here, they would be able to assume both of these roles. But you can see, this is a little bit different than the last pattern. There's a OU specific permission set. So when I update this permission set, it's the configuration for these roles, but we have a separate permission set here that we use for roles outside of the data science organizational unit. And lastly, you can do the one-to-one mapping, which is similar to the one from the AWS IAM Federation pattern, and is essentially the most fine-grained option. This may be a good option to start off with if you're looking to migrate over to using AWS SSO from the AWS IAM Federation pattern, since you already have the groups created, the users added to those groups, so you could essentially just reuse those. In this option, you create separate groups for each AWS account and job function combination, and either use the same job functions permission sets across all the accounts, which is what's shown here. So you can see if I were to add a user to this particular group here, they would have access to only assume this role in this AWS account. But the permission set to AWS account mapping is one-to-many. So I'm reusing this permission set across a bunch of different AWS accounts. So if I were to update policies related to this permission set, it would change the configuration of all of these roles. So as you start to think about which direction to go, be sure to verify the service quotas to ensure it will meet your requirements. Now I'm going to hand it off to Yuri to walk through the user flow.
Thank you, Jesse. Now, let's take a closer look at what happens in the user authentication flow while federating AWS accounts access with AWS SSO. First, user opens a browser and navigates to the AWS SSO user portal URL. There, he has been prompted for the username, password, and optionally second-factor authentication. AWS SSO authenticates user against either internal directory store or Microsoft AD and presents the list of AWS accounts and roles assigned to this user by the AWS SSO administrator. User chooses AWS account and role he'd like to log in with, and then AWS SSO generates a SAML assertion and browser posts it to the AWS SAML endpoint, which calls AWS STS to get temporary IAM credentials, and finally user redirected to the AWS console to access AWS services. As far as you can see, this is an IDP-initiated SAML flow where AWS SSO is the identity provider and AWS accounts are the service providers. We'll come back to the AWS SSO Single Sign-On flow again later on, but meanwhile, let's talk about another very important benefit of federating accounts access with AWS SSO. If you are using direct federation with AWS IAM and you want your cloud builders to use temporary AWS credentials while accessing AWS accounts from CLI, you need to implement some custom wrappers or possibly to use some open source solutions. In general, you need to let users sign in with the identity provider, grab the SAML assertion generated by the IDP, and call assume role with SAML STS API to get credentials. When you are federating your accounts with AWS SSO, you don't need to instrument any of this. AWS CLI v2 natively integrates with AWS SSO today and enables your builders to use temporary AWS credentials natively. When you have AWS CLI v2 installed, you can type AWS configure SSO, provide the AWS SSO start URL and AWS SSO region. Then AWS CLI will open your default browser, directing you to the AWS SSO authorization page. If the machine you are working on doesn't have a browser, you can open this URL on any other device, even on your mobile phone, enter the device code, and after successful authentication by the AWS SSO, authorize the CLI session. Next, you'll be presented with the same list of accounts and roles that is assigned to you by the AWS SSO admin, and when you choose the specific account and role you'd like to assume, AWS CLI will obtain temporary AWS credentials and will let you to set the session profile name. Let's quickly summarize this access pattern and compare it with the direct federation one. With AWS SSO federated access, your identity source of truth is the AWS SSO or Active Directory it's connected to, user authentication controlled by the AWS SSO, AWS SSO tightly integrated with AWS organizations so you can manage access to all of your organization accounts centrally. With AWS SSO, you manage IAM roles centrally, and IAM roles created on the accounts are immutable and managed by AWS. Groups to IAM roles mapping is flexible. You can assign access to the same group and provision the same permission sets to multiple AWS accounts, creating an account control model that suits your organization the best. Also, your builders can obtain temporary AWS credentials using AWS CLI. This pattern is trending today, although you probably will ask now, what happens if I already have my identity provider? So let's talk now about the third AWS accounts access pattern, federation with external identity provider using AWS SSO. It's very common that customers adopting AWS Cloud already have an identity provider of their choice, and this federation model enables customers using the same existing identities to access AWS accounts and services, managing this access from one single place. We recently released a number of new AWS SSO features and integrations, such as Account Assignments API that we just talked about, as well as automated users and groups provisioning using SCIM. So first, let's look like how we integrate AWS SSO with an external identity provider. We start from configuring SAML 2.0 federation between AWS SSO and external IDP. Configuration nuances really depend on the IDP, but in general, we set AWS SSO identity source to the external IDP, configure relying party on the IDP. It may be done either via SAML metadata exchange or manually. With AWS SSO, we assign users and groups access to AWS accounts in AWS SSO, which means AWS SSO has to know about our users and groups. We can provision users and groups manually in AWS SSO, but this is obviously not the best approach. To address this, AWS SSO supports users and groups information synchronization between external IDP and AWS SSO using System for Cross-Domain Identity Management Protocol, or SCIM. Today's SCIM integration is officially supported for Azure AD, Okta, and OneLogin. We also have published AWS SSO SCIM API that you can use to develop your own SCIM connector to use with AWS SSO. So to configure SCIM automatic provisioning, we'll enable SCIM endpoint on AWS SSO and configure it on the IDP side using the bearer token generated by the AWS SSO for authentication. Next, we need to create or to choose from the existing IDP groups that will be assigned access to the AWS accounts. Note that AWS SSO doesn't push any information back to the IDP, so SCIM provisioning works only one way. When IDP administrator will add or remove users from these groups, SCIM provisioning will push these changes to AWS SSO. As soon as we have IDP users and groups synced up with the AWS SSO, the steps are the same as in previous federation pattern with AWS SSO. We create permission sets and assign access to the groups to the AWS accounts. Same as with direct federation with AWS SSO, you can choose the groups to roles matching pattern that suits your organization needs. You can choose the model of one-to-one mapping IDP groups to AWS accounts and to use the same job functions permission sets as on this picture, or you can scope down your IDP groups, mapping them one-to-one to the permission sets and assign to multiple AWS accounts, exactly as we discussed in the previous scenario. Let's look at how you can automate your AWS accounts access management with an external IDP and AWS SSO. First, your automation solution creates a new group in the IDP and assigns this group to the SCIM provisioning. The new group will be pushed to the AWS SSO by SCIM. Next, your automation checks if the group already appeared on the AWS SSO side using AWS SSO Identity Store API. It may take some time till the group will be synchronized depending on your IDP SCIM implementation. Next, automation creates a permission set using AWS SSO Account Assignment API. This step may be skipped if you are reusing the same permission set for the new group. Then automation creates account assignment for the group with the permission set. Note that you don't need to automate role and policies creation on each AWS account these groups users will be accessing. When you add users to the group and the group membership will be pushed to the AWS SSO, they can access AWS accounts and services. This is very high-level flow that you can customize further. For example, as AWS SSO administrator, you can pre-create a number of permission sets and delegate permission sets management to a different AWS user. Let's say you create a permission set for DevOps engineers working on the data lake project, and you tag that permission set with the tag project equals data science. AWS SSO permission set supports tag-based authorization control today, so you can let data science project admin to customize and to assign this permission set to the data lake engineers by assigning him the policy similar to this one. IAM role that will have this policy allows to work with any permission set that tagged with the policy tag data science. Now, let's take again a closer look at how user is getting authenticated in this scenario. User opens a browser and navigates to the AWS SSO user portal URL. To authenticate the user, AWS SSO generates SAML request and redirects user to the IDP for authentication. User browser sends the SAML request to the IDP and user authenticates there as defined by the IDP administrator. Next, IDP generates SAML assertion response and redirects user to the AWS SSO SAML endpoint. This part of the authentication process is SAML SP initiated single sign-on scenario, where AWS SSO is the service provider and the external IDP is the identity provider. IDP initiated single sign-on is also supported. User may first log in to the IDP and choose AWS SSO application there. Let's quickly look at the SAML assertion generated by the IDP. You can see that it contains only the name ID, which is the user email address and nothing else, comparing to the direct IDP IAM federation model where the entire list of roles and the session duration are included in the SAML assertion. So the SAML response size is not longer an issue here. In this model, the roles assignments to the accounts been controlled by the AWS SSO and the session duration configured in the permission set definition. Based on the user's identity from the assertion, AWS SSO presents user with the list of accounts and roles this user can assume. User chooses the account and role from the list, and AWS SSO generates another SAML assertion and redirects user to the AWS IAM SAML endpoint. Let's quickly look at this SAML assertion now. You can see that the SAML assertion from the AWS SSO to IAM contains the session name and the session duration, similar to the one we've seen from the external IDP in the direct federation scenario. Again, in contrast with the direct scenario, this SAML assertion has only a single IAM role that references the immutable role created by the AWS SSO. Next, browser relays the SAML response to AWS IAM, which calls assume role with SAML, gets temporary AWS credentials on behalf of the user, and redirects user to the console. Finally, user can access the console. So this is the second SAML flow in this scenario between AWS SSO and AWS accounts. AWS SSO plays an identity provider role here, and AWS accounts are the service providers. Only the IDP initiated scenario is supported here. Now, after we talked a lot, it's time to show you a demo. We will start from the user experience, signing into an AWS account with AWS SSO, and an external identity provider. I have my AWS SSO console open here, and I've already configured SAML to the trust and automatic users and groups provisioning using SCIM. In this demo, I am using Okta Universal Directory as the identity provider. As AWS SSO administrator, I need to provide my users with AWS SSO start URL that can be found on the AWS SSO console in the Settings tab. My users will use this URL to sign in with AWS SSO from AWS console and from AWS CLI. Now, as AWS user, I start the sign-in process from navigating to this URL. My AWS SSO identity store set to the external ADP and SAML federation with Okta already configured, so I'm redirected to the Okta sign-in page with the SAML request. I provide my credentials here, and after authentication, I am redirected back to the AWS SSO with the SAML response from my IDP. This SAML assertion carries only the information about user's identity. I already assigned some access to my AWS organization accounts to this user, so AWS SSO presents me with the AWS accounts and roles I can assume. I choose one of the options from the list, and AWS SSO generates the SAML response that contains the single role I am going to assume in this session, the session name together with the session duration defined in the permission set. It redirects me to AWS IAM SAML endpoint, and I get credentials for my session, and I can access my AWS account. As far as you can see, it's very convenient for the users to sign in to AWS accounts with AWS SSO. If you'd like to learn more about how to use and configure AWS SSO with external identity sources, you can watch our AWS SSO webinars using AWS SSO with Okta Active Directory and AWS SSO identities, and how to use Azure Active Directory with AWS SSO. In the second webinar, you can also find a demo how to obtain temporary AWS credentials for AWS accounts from AWS CLI. Now, I'll show you something new and exciting, and we never demoed it before. Together, we'll take a look at how to manage AWS SSO permission sets and account assignments using AWS CLI. I'll go to the AWS console as AWS SSO administrator. The first thing that I need to do is to get information about my AWS SSO instance. I type AWS SSO admin list instances and note the AWS SSO instance ARN and the identity store ID. We will need both of them down below. Then, similar to how we do it in the console, I create a permission set. I have to provide the SSO instance ARN a name and description for the permission set I am creating. I also can set a session duration while creating the permission set, but I leave it at default, which is 1 hour. I created the permission set and got its ARN back in the response. At this point, this new permission set doesn't have any permissions attached to it, so now I attach an AWS Managed Policy to this permission set. It's possible to attach up to 10 AWS Managed Policies and 1 inline custom policy to the permission set, but I attach a single one for this demo. I am providing the ARN of the Security Audit Managed Policy and attach it to the permission set. To check that the policy has been attached successfully, I run list managed policies command for this permission set and I see my security audit policy there. Now I'd like to assign access to the security audit group that I created in my Okta directory to my development account with the permission set I've just created. My Okta security audit group has been synced to the AWS SSO identity store, and I need to retrieve its group ID. I use AWS SSO Identity Store API and call list groups using the identity store ID I've got from the list instances before. I apply the search filter to the group display name And when I have a group ID, I'm going to create an assignment. I call create account assignment API and specify AWS SSO instance ID, permission set ARN, principal type group, it can be either group or user, and its ID as well as AWS account ID I'd like to assign access to. I see that my account assignment is in progress, so I call describe account assignment creation status API to see if the assignment was successful. Now, if I add users to the security group in my IDP, the group membership will be pushed to AWS SSO with SCIM, and they will be able to access this AWS account with the permissions defined in the AWS Managed Security Audit Policy. To complete this demo, let's quickly take a look at the permission sets provisioned on that account. I call list permission sets provisioned to account and see that there are 2 permission sets provisioned there, and the security audit is one of them. I can also check what are the accounts assigned with the permission set using the list account assignments API. You can use these APIs for AWS account access audit and governance. As far as you can see, now you can manage AWS SSO account assignments from AWS CLI. You can also use AWS SDK for the language of your choice and AWS CloudFormation to build your account assignment automation. Let's now summarize the last federation option we discussed, federating your AWS accounts access with AWS SSO and using an external identity provider. While you're using this access pattern, your identity source of truth is your IDP, and it also controls users' authentication. As well as the second scenario, the direct federation with AWS SSO, this one also benefits from the AWS SSO integration with AWS organizations. IAM roles management is centralized, and AWS SSO manages immutable roles on your accounts. Your builders can also obtain temporary AWS credentials using AWS CLI. This pattern is emerging today, and we keep adding new AWS SSO features and integrations such as SCIM automated provisioning, account entitlements API, and more. And I'd like to emphasize this again, we recommend using federation while accessing AWS accounts and services, and to consider using AWS SSO to manage your users' access centrally. Jesse, it looks like we have some time left for questions.